They told us it was impossible. That nothing, not ships, not information, not even thought, could ever travel faster than light. It wasn't just a rule. It was the rule. Written into the universe itself. A cosmic speed limit imposed by Einstein's equations. Ironclad, elegant, and absolute. For over 100 years, it held firm, as if the universe itself was saying, this far and no farther. But what if it lied? Today, behind locked doors and inside machines that hum with unimaginable precision, scientists are beginning to ask the unaskable. What if we don't need to break the speed of light? What if we can cheat it? Not by brute force, but by turning space into our ally. Not by pushing harder, but by warping the road itself. This isn't fiction. It's happening right now. Let's put this in perspective. Light travels at 299,192,458 meters per second. That's over 1 billion kilometers an hour. Yet even at that speed, it takes over 4 years to reach Proxima Centauri, the nearest star system. A distance so vast, even light feels slow. Our fastest spacecraft? The Parker Solar Probe. At top speed, it would take more than 70,000 years to get there. In cosmic terms, we're barely crawling. And that's the problem. The universe is not built for the impatient, but humans are not built for waiting. We are restless. We look up at the stars not just with curiosity, but with longing. We want to go. And now, for the first time, we might finally have a way. It all began in 1994, when physicist Miguel Alcubierre proposed something radical. What if, instead of moving a ship through space, we moved space around the ship? A bubble of space-time, contracting in front and expanding behind, carrying the vessel like a wave carries a surfer. Inside the bubble, no movement, no speed limit broken. Yet from the outside, the craft appears to move faster than light. It was elegant, brilliant, and completely impractical. The energy required was astronomical, literally. Worse, it demanded exotic matter with negative mass, a substance that might not even exist. But the math worked. For decades, Alcubierre's drive was a beautiful impossibility. A perfect idea with no path to reality. That is, until NASA's Harold G. White entered the picture. In 2021, White and his team made a discovery that sent ripples through the scientific world. While studying quantum vacuum phenomena, specifically the Casimir effect, they stumbled upon something extraordinary. A naturally occurring warp-like structure. Microscopic but real. Not a theory, not a simulation. An actual warp bubble. It was tiny, a mere fraction of a millimeter, but it was enough. If such a structure can exist on the quantum scale, the question isn't whether warp fields are real, it's how to make them larger. White's team began exploring designs that could drastically reduce the energy requirements. Through clever geometric adjustments, they lowered the amount of negative energy needed from the mass of Jupiter to something closer to a few hundred kilograms. Suddenly, warp drive was no longer just theoretically possible. It was technologically approachable. But that's just one thread in a rapidly weaving tapestry. In Germany, a team of physicists took warp theory into the realm of gravitational waves. Using complex simulations, they modeled how a real warp drive might disturb the fabric of space-time, and what those distortions would look like when detected from Earth. The hope? That somewhere, in the data from gravitational wave observatories like LIGO, we might find echoes, shadows, signatures of alien warp technology. That's right. If other civilizations out there are already using warp propulsion, we might detect their movements, like seeing ripples in a pond after something slips beneath the surface. If we can recognize those patterns, we might not just observe them, we might replicate them. Reverse engineering warp technology from across the stars. And this isn't just about travel, it's about survival. Our planet, beautiful, fragile Earth, is hanging by a thread. Climate change, resource depletion, cosmic threats we can't even see coming. There is no second Earth in our solar system. Mars is a graveyard. Venus is hell. If humanity wants to survive long-term, we must look beyond. Faster-than-light travel isn't a luxury, it's a lifeboat. And more than that, it's destiny. We were never meant to stay here. Our minds reach too far, our questions go too deep. There's something in us, ancient and unyielding, that needs to know what lies beyond the next horizon. Not just because it's there, but because we are wired to explore, wired to risk, wired to wonder. Of course, challenges remain. Warp models are still unstable at large scales. Some suggest they could distort local space-time dangerously, or even tear it apart. Others warn of paradoxes, situations where cause and effect could reverse, breaking our understanding of reality itself. But history is built on the bones of impossible things. Flight was impossible, until it wasn't. So was the moon. So was quantum computing. And one day, faster than light travel will join them. Imagine a future where ships don't fly across the stars, they slide, through folded corridors of bent space-time. Journeys to Alpha Centauri in a week. Contact with civilizations thousands of light years away. Real-time communication via space-time channels. Energy harvested from folded geometries. Even control over time itself. It may sound like fantasy, but today's science fiction is tomorrow's launchpad. Somewhere, right now, an engineer is refining a warp geometry. A physicist is balancing equations no one solved before. A probe is being built that will one day slip into a space-time fold and emerge in a different star system. Not in 1,000 years, maybe not even in 100, but within our lifetime. And when that day comes, everything changes. We won't just explore the universe, we'll become part of it. Not bound by distance, not limited by time, but free to wander, to connect, to evolve. So keep your eyes on the stars, not for what they are, but for where they will take us. Because the road to the impossible has already begun, and we are the ones who will walk it.